we are Group 11 of the Fall 2019 to Spring 2020 Capstone Design class, and we will be presenting our Caterpillar Swivel Joint Subassembly Line Conveyance project. The problem assigned to us involved changing the swivel joint subassembly from a batch-style process to a conveyor. The batch-style process was deemed to be too inefficient. Our project scope includes determining which type of conveyor to use, determining the layout of the conveyor, designing the conveyor itself, and designing a pallet upon which the swivel joint will ride. Our constraints include cost, safety, ergonomics, and cycle time. For cost, we had an absolute maximum price of $20,000. This entirely ruled out using a powered conveyor system, as it would be too expensive. The conveyor and pallet must be an inherently safe system, able to take the weight of the swivel joint and transport it without risk of injury. With regards to ergonomics, the conveyor must be comfortable to use and easy to maintain. Line workers may be working on this conveyor for up to 12 hours at a time. The design conveyor must also meet or exceed the throughput required by the main assembly line.
Our conveyor system uses a two-story design. The primary structure of the system is made by extruded aluminum bars. To these extruded aluminum bars, we have attached a C-channel that holds the rollers for our conveyor. The top of the conveyor is where the assembly will actually take place. These rollers are not inclined, and workers push the pallet with the assembly from one station to the next. There are a total of 5 4-foot stations for a total conveyor length of 20 feet. The bottom conveyor is where the pallets will be returned from the end of the conveyor back to the start. This conveyor uses the same rollers and C-channels as the top conveyor. However, they're slightly inclined to allow gravity to return the pallet. The conveyor is approximately 40 inches tall by 24 inches wide, making it ergonomically friendly for the workers during the assembly process. The swivel joint itself sits on the pallet and rides down the conveyor for assembly. Hoses are attached to the swivel joint during this assembly process, which pass through the holes in our pallet. The pallet itself is made from lightweight aluminum and has handles attached on either side to make it easy for workers to lift. Once the pallet is on the conveyor, detent pins at each station prevent the pallet from rotating or moving further down the station once they're locked in. The C-channels that also support the rollers for the conveyor serve a dual purpose by not allowing the pallet to rotate vertically off of the conveyor. The aluminum sheet below the main conveyor supports the hoses during assembly and keeps them from hitting pallets on the lower conveyor as well as getting contaminated from the ground. This keeps the hoses safe from damage.
By implementing our conveyor system, our team estimates that the swivel joint cycle time could be reduced by 20% based on time trials that we performed. The conveyor design is a centralized process, unlike the batching process, which means it would eliminate key problem areas like time spent not in station, time spent retrieving parts, time spent transporting components, and time spent just walking around the station. The conveyor also would allow us to implement a rack to store tools, which will eliminate the time wasted retrieving and returning tools. Our team was able to accomplish this reduction in cycle time while also keeping safety and ergonomics in mind. From a safety perspective, our team included a pallet that pins to the swivel joint, preventing it from falling. Our pallet is also locked into the conveyor by using tightly fit C-channels, meaning that it is not at risk to fall off the conveyor. Finally, our team kept safety in mind when designing the return conveyor. It is an incline of only 1.1 degrees, meaning that a pallet will only travel at a maximum speed of around 1.5 miles per hour down the conveyor. From an ergonomic perspective, our team designed our top conveyor to be at the height of an average person's elbows when they're down by their side, which is around 40 inches. This makes it comfortable to work on throughout the day. We also place line workers on either side of the conveyor so that they don't have to reach across the conveyor itself to install one of the hose fittings. In terms of the return conveyor, our team placed height at nearly 3 feet at the end, meaning that workers do not have to bend down far to reach the returned pallet. The pallets are also made out of a lightweight aluminum, which eases the load for line workers to lift.